Okay, in the main shaft keyway video, I showed you one way of looking at your mesh visually by using the cross sections in addition to inspecting the surface. But often we want to be able to look at something a little more numerically. If we come back and we look at our mesh and we do the note, we can see that I have over 200,000 elements, right? And what are the odds I'm going to see all the good elements? So one of the things I can do is look at my quality of my mesh and check some statistics. And there's a couple of functions here. I can see I'm going to check for both errors and warnings. Normally it just says yes, errors, but I can check for errors and warnings. And I can set a target quality. This defaults to 0.05. I raised it to 0.25, which I think causes it to do a little more iteration and try to improve some of the bad meshes. And then you can see statistics. Our min quality was 0.08 on a scale of 0 to 1. Our max is basically perfect. And the average, you can see kind of that average, that's a reasonable value. Now I can also create a histogram of the metrics that we have. So you see down here that I've got, with this check on, it's created a mesh metrics tab here. Sometimes if you have this small, you may not see anything. But I can drag this up so I can see this a little bit better. And I can come in here and set some controls. So I'll reset this to the default. And you can see, yes, it peaks at this high quality, it drops off, and I have a few down here. Now, on a scale with having 620,000 of these good elements, it's really hard to see how many of the bad elements I have. So I could, for example, come in here and reset the y-axis, close that. Now I can, so I can see now. Well, that's 115 or so of those. And you notice when I click on them, it highlights where they are. So I can come in and I can say, well, some of these I may not care much about, but others may be really important. Like, here I'm in the fillet, but it's not. It's probably not in the region, so I probably have my peak stresses near where one of the keys are, and it may even say, I don't really care about the fillet, so that's not the main focus of this analysis, and you may not have even refined it there. But and this up here isn't too big a concern, because again, that's out of the main areas, but I might be a little more concerned about some of these elements. Okay, so you can kind of see where they are, but they're sporadic, and they're not, and probably the worst case is up in here, so then if so, then I probably don't need to worry more about those. But you can do that for each of the quality levels. You can see now I have some more that are along this fillet that may be of a little greater concern. Okay, so you can see where that is, and you could look at that and compare that. Though this is somewhat conservative, right? I said it was normally 0.05, and I can set that to 0.05. You notice it's going to tell me my mesh is obsolete, and I can come back through and update it. And I'll pause this while it remeshes, and then we can take a look at the difference. Okay, so after I updated that, it remeshed, and now I can come back to my quality, and we have an updated plot here. So it looks like we have 100, and notice that the minimum is somewhat lower. It's just above that target of 0.05. So I can again look at those, see where they are. Some of them are in corners that are off the loaded corner, so it may not be a concern. But that's you can see that trade-off. The elements got better when I set a higher target there. And you can see, now this might be a bit concerning. I've got a bunch in this lower range here. Now, I don't know the estimate, the point at which that is a concern. It's not something I have knowledge of, but it's important that you be able to see where these are and be able to make so that you can be aware that you're lower end and you may have poor quality elements in areas of interest. Okay, so let's look at a few other meshing things that we can do here. One, in our mesh, sometimes you don't care about features smaller than a particular subset. So you could come down here to feature size and maybe make it 0.05 and create a mesh, and that would allow it to simplify around small features that don't need to be resolved in the mesh. And will simplify your mesh, though you're not going to get as accurate results around those areas. So if I was worried about deflection of the shaft, that would be a perfectly fine solution to do in this case. Or if I was interested in stresses at a different location. You can see that that's a very coarse mesh, though, and even deflections might be a little bit questionable. But I could go ahead and defeature that separately from the course, from the size of the mesh. Right? Now, another thing you notice is I've got these tetrahedral elements. As we discussed before, it's more accurate to put in brick elements. So one of the options in here is a method. And so it's going to choose automatically. When it's a simple shape, it will, let's go ahead and apply that. It's going to default to a hex mesh where if it can do it readily. Though sometimes you can kind of encourage it to do a few things that would be to go that direction a little bit more. So its defaults to automatic, and I can force it to tetrahedrons, which is the default here, the pyramids. Sweep is a good way of doing it, where it meshes a face with square elements, and then it sweeps that through the area. So if you have an extruded shape or a revolved shape, that works very well. Multi-zone is a technique where it tries to split that up into smaller pieces that can be swept. And the hex dominant means it's going to mix in the hex and tetrahedral elements. So let's just try a couple of these and see how it does. The keyways make this a challenging problem to mesh with the full hexahedrals, and it may fail, but let's just give it a chance. So let's try a multi-zone, and we'll update our mesh and see how it does. Okay, so we tried to mesh that. You can see that it came up with some errors. It couldn't do it that way. Not a big surprise given this, but let's go ahead and see what a hex dominant mesh option would do. Okay, so we'll come down here and we'll select hex dominant, and then we'll remesh and see what solution we get. Okay, so let's show the mesh. Okay, and indeed it was able to do a hex dominant mesh. And again, we still have our defeature, we have our fine settings on there. So this isn't probably a mesh you'd want to use in this case, but it's one that you might use that technique to improve your solutions and get accurate solutions in combination with some of the refining and mesh sizing information settings that we've talked about before.